All right, let's look at number 1 in this purple section. So we're going to solve each equation by using a common base or take the log of both sides. So for this one, I noticed that 9 is the same as 3 squared to the x minus 5 power equals 3 to the x plus 8 power. So what I can do then is I can take that 2 and distribute it to the x and the minus. This would be the same as 3 to the 2x power minus 10 equals 3 to the x plus 8 power. So remember what an equation means, or an equal sign means, is that the two sides are equivalent to each other. So we're trying to figure out what would you have to do for x to get both sides to be the same. And we already have the bases the same, so let's figure out what we'd have to get for the exponent to be x, or our value for x there that would make those exponents the same. So we're just going to solve this equation. So I would subtract x from both sides. When I do that, 2x minus x would just give me x. And then I would add 10 to both sides, and I would get 18. So x would equal 18. And you could plug that in your calculator. You could put 18 in for x into both sides of that equation, and you would get the same answer on both sides. All right, let's look at number 2. Number 2 is going to be very similar to the first one, where we're going to change this to have a common base. So 8 would be the same as 2 cubed. Whoops. And that would still have an exponent of 2x minus 3. And on the right side, 4 would be the same as 2 squared, and that would have an exponent of x plus 3. So what we're going to do is we're going to distribute the 3 on that side, and we're going to distribute the 2 on this side to both of those other terms. And so here we would have 2, and then 3 times 2x would be 6x, and then 3 times negative 3 would be minus 9. So we'd have 6x minus 9 as your exponent on the left. And on the right, our exponent, we distribute the 2 through, so we get 2x plus 6. So again, we're trying to figure out what x would have to be for these two sides to be equal. The bases are already equal, so let's just focus on the exponents. The 6x minus 9 equaling the 2x plus 6. So what I'm going to do is I'm going to subtract 2x from both sides. So now I would have 4x on the left. Then I'm going to add 9 to both sides to get 15 on the right. And now divide. So to find x, we just divide both sides by 4. So we get 15 fourths. That can't be reduced at all. So that would be your answer. X would equal 15 fourths. All right, let's look at number 3. So with number 3, there's nothing we can do to the base for 3 and 5 to get the same base. And so what we're going to do is we're going to solve this equation by taking the log of both sides. And so if I take the log of both sides, I would have log of 3 to the x power, but remember that x we would put in front of the log, equals, and on the right side here, the exponent is x minus 2, and that's going to go in front of the log. So I'm going to put that in parentheses. So it'll be the log of x minus 2, or x minus 2 times the log of 5. And now the next step, we're going to distribute that log of 5 to everything in parentheses. And so the next thing I'm going to do is I'm going to get all my variables on one side of the equation and my numbers without a variable on the other side of the equation. So I have x log of 5 on the right that I want to get to be on the left. So I'm going to subtract it from both sides. So we'd have x log of 3 minus x log of 5 equals negative 2 log of 5. All right, so now on the left side, I'm going to factor out an x from all of that mess. And so we have x times the log of 3 minus log of 5 equals negative 2 times the log of 5. So to solve for x, I'm going to divide both sides by log of 3 minus log of 5, that entire quantity. Now, if you wanted to do that on your calculator and get a decimal, that's totally fine to do it that way. But I'm just going to write it like this. We'd have x equals, so we'd have negative 2 log of 5 divided by that entire quantity, log of 3 minus log of 5. And when you do that, you get 6.301 as your final answer. Okay, let's look at number 4. So for number 4, we're going to do the same thing, because with the 4 and the 7, there's no way to change that base, so they would have a common base there. So we're going to take the log of both sides. So when I take the log of both sides, we would have x times the log of 4, because that 4 would have an exponent of x, which the x then would move in front of the log, equals, and the same thing's going to happen on the right side. So I'm just going to write the x plus 1. It's important to put that in parentheses, so we'd have x plus 1 times the log of 7. And so what we're going to do now is we're going to distribute that log of 7 through. So we'll have x log of 4 equals x log of 7 plus 1 times the log of 7, or just log of 7. So I want to get all my variables on one side of the equation, so I'm going to subtract the x log of 7 from both sides. And then I'm going to factor out an x, because both of those terms have an x in common. So we factor out an x there. So we'd have x times the quantity log of 4 minus the log of 7 equals the log of 7. So now to solve for x, now again, you could take log of 4 minus log of 7 on your calculator and just write out what that would be as a decimal. Otherwise, we could write it like this. So we'd have log of 7 divided by the entire quantity, log of 4 minus log of 7. And that you just, like I said, you just type that in your calculator. You just want to make sure that you're careful when you're typing it in your calculator, make sure that you do it all correctly. And when you do that, you get negative 3.477 as your answer for x. And again, for both of these problems, you can always double check your answer by plugging in this answer for x into the original equation, not anything that you did on your own, but in the original equation. And since we rounded, you won't get the exact value on both sides of the equal sign, but you'll get really close to the same value on both sides of the equal sign. Speaking of checking our work, we're going to have to do that in the next two problems, because we're going to have to check to see if we have extraneous solutions after solving these. So the first thing I do is we need to use those properties of logarithms, and I see that this 2 is in front of the logarithm, so that means it's an exponent for the x. So this will be the same as a log of x squared equals the log of 3x plus 4. So we could take the inverse log of both sides and get rid of the logs, because essentially what we're doing is we're trying to figure out what value for x would make both of these sides equal to each other. So we'd have x squared equals 3x plus 4. So this is a quadratic that we're trying to solve, so we want to get everything together on one side. So we'd have x squared minus 3x minus 4, because I'd subtract 3x from both sides and I'd subtract 4 from both sides. And now we're going to factor this down. So when I factor this down, again, we're trying to find two numbers that multiply together to be negative 4 that add together to be negative 3. So that's going to be a positive 1 and a negative 4, because 1 times negative 4 would be negative 4, and positive 1 plus a negative 4 would be negative 3. So that would be their factored form. And so to solve for x, we're going to set each of those equal to 0. When you do that, we get negative 1 and positive 4. But it could be that one or both, neither of them could be extraneous solutions. So we've got to check to see, are they extraneous? So let's start with the negative 1. Again, we're going to put this back into I'm going to actually put it into this form, because even if I put negative 1 in for x, we're still going to have to apply that 2 to an exponent. So I'm going to look at this as being the log of the quantity negative 1 squared. I want to see, does that equal the log of 3 times negative 1 plus 4? So on the left side, negative 1 squared would be a positive 1. On the right side, 3 times negative 1 is negative 3. Negative 3 plus 4 is 1. So we get the log of 1 on the left and the log of 1 on the right. So that one worked out. Okay, so now let's check with when x is 4. So we'd have 4 squared. We want to see, does that equal the log of 3 times 4 plus 4? So 4 squared is 16. So we get log of 16. On the right side, we get 3 times 4 is 12, and 12 plus 4 is also 16. So that also checked out, because both sides are the same. So that means that both of those are actual solutions to that equation. Let's look at the last one. So the last one, we're going to do the same way. So this 2 would be an exponent for the x. This would be the same as a log of x squared. On the right, we'd have the log of negative x plus 6. So again, we could take the inverse log of both sides to get rid of the logs, because essentially what we're trying to figure out is what value for x would make these two sides equal. So another way would just be to ignore the logs, because we're trying to figure out what values for x would make the log of x squared equal the log of negative x plus 6. Okay, so now we're going to solve this, because we want to get everything on one side of the equation. So I'm going to add x to both sides and subtract 6. So then we're going to put this in factored form. So I'm trying to figure out what two numbers multiply together to be negative 6 that add together to be 1. Well, that would be a negative 2 and a positive 3. Because negative 2 times 3 would be negative 6, and negative 2 plus 3 would be 1. And so now to solve for x, we would set each of those equal to 0. And so when I do that, I get x equals a positive 2, and x could equal a negative 3. But remember, it could be that maybe we would have an extraneous solution here. So let's see if that's the case. And so I'm going to check this with the first one when x is 2. So again, I'm going to check it with this one here. So we would have the log of 2 squared equals the log of negative 2 plus 6. Well, 2 squared is 4, so we'd have the log of 4 equaling, and on the right side, negative 2 plus 6 is also 4. So we'd have log of 4 equals log of 4, so that checks, so that worked out. So we're going to do the next one, negative 3. So we would have the log of negative 3 squared. We want to see, does that equal the log of, now this would be a negative 3, which would make that a positive 3 plus 6. Well, negative 3 squared, sure enough, that's a positive 9. And over here on the right, 3 plus 6 is also positive 9. So that also checks, so both of those are correct answers. So there are no extraneous solutions in that one either. And that's it. So hopefully that answers the questions that you had from this purple section.